Hello, everybody, and a very warm welcome indeed. I'm your friendly host, Gareth Mitchell, and I'll be your moderator for this deep dive session from Frontiers in Science. Now, if you don't already know us, then welcome aboard. Frontiers in Science is our flagship multidisciplinary open access journal, and we're home to the very best peer reviewed lead articles on transformational science, tackling the many challenges that we and our planet face every single day. Now, we publish our articles across unique hubs and we cater for all kinds of audiences, basically anyone involved with or interested in science, policy, and society. And we have quite a back catalogue. We've been busy. So far, we've built 32 hubs with over 120 articles across all kinds of sciences. We've been cited over 1,400 times and we've had nearly 4 million views. And we're always getting picked up by the media. So you may have seen our work on the news. So let's tell you about today's lead article. It's called Balancing Food Safety and Sustainability, Trade-off Risk Assessments and Predictive Modelling. And leading that very important work is Professor Martin Wiedmann, and it's really good to host the article and its associated hub. So then, would you risk eating a food if I told you it was less than 100% safe? I mean, I couldn't blame you for hesitating. Food poisoning, as we all know, it's not nice, is it? Being sick, having stomach cramps, going to the toilet every few minutes. Disgusting. But of course, most of us, we do get back to normal after a day or two. But for many around the world, of course, foodborne pathogens can be a serious and dangerous problem. The most severe infections can spread from the gut to the blood or the brain. They can knock out someone's kidneys or even cause a pregnant person to lose their baby. Infected food actually causes an estimated 600 million illnesses and 420,000 deaths every year around the world. And of course, bad food is bad for business. Food poisoning outbreaks can shut down processing lines in factories, they can cause grocery retailers to clear their shelves, or they can force cruise ships back to port. So I ask you again, here's some lovely tasty food, but I can't guarantee you it's completely safe. Are you sure about eating it? But then, of course, the thing is, if we insist on absolutely safe food every time, then we'll just end up throwing a whole load of stuff away and the system will end up being unsustainable. So we need to trade some safety for practicality and sustainability. Our Frontiers in Science lead article and this deep dive are all about where that trade-off lies. And it matters. Food safety is the subject of World Health Organization strategies and 3 of the UN's Sustainable Development Goals. Our lead article argues that food should be sufficiently safe, satisfying clearly defined public health protection aims rather than chasing some kind of unattainable goal of completely zero risk. The technology for detecting harmful microbes, of course, that's improving all the time. And all that data is driving machine learning models to help predict risk and assist policymakers and industry. So, today, what do evidence-based decisions look like? Where does governance come into it all? How can we best evaluate and compare food safety measures? And by the way, do you still fancy that food that we've just been talking about? Now, of course, do stay with us and join the conversation as we explore cutting-edge microbial risk assessments, geographic information system models, and AI-driven predictive tools, ushering in a future of smarter, more transparent food safety decisions and plentiful, sustainable, safe enough food for us all. So there you go. That sets the scene. I hope it's whetted your appetite. Excuse the pun. But before we get going in earnest, let me just show you around a little bit. This is the article hub. And alongside the lead article, we have an editorial by Dr. Ana Allende from the Spanish Research Council and Dr. Sarah Bova Cid from the Institute of Agri-Food Research and Technology, also in Spain. There's a viewpoint article by Professor Lee Ann Janus from North Carolina State University and a policy outlook by Steve Wern from SJW Consultancy. And by the way, don't worry if you're a beginner, because we have a lay explainer on the hub, and there's also a video and an article, especially for younger readers in our Frontiers for Young Minds Science Journal for Kids. Let's take you through our schedule now then. First, we're going to hear from the authors of the lead article, Professor Martin Wiedmann, Sriya Shunil and Professor Sophia Euler. And then we'll open things up for a panel discussion with Steve Wern and Frank Yanis. Let's get down to business. And we're going to start by saying hello to Martin Wiedmann, Gellert Family Professor of Food Safety at Cornell University, a leading expert in farm-to-table microbial food quality and safety. His research focuses on the ecology, transmission, and control of foodborne pathogens. Martin has developed risk-based approaches that balance public health protection with environmental and economic considerations. He's a fellow of the American Association for the Advancement of Science, the Institute of Food Technologists, the American Academy of Microbiology, and the International Academy of Food Science and Technology. In other words, he's incredibly busy. We're very glad to have him along. Martin, over to you. Let's hear what you have to say.
Great. Thanks, Gareth. And I'm going to start us out this today with talking about the current food safety challenges and the challenges of the food systems as it relates to food safety. As Gareth already pointed out, foodborne illness are common in the US. The estimate is that 1 out of 6 Americans contracts foodborne illness every year, which results in about 130,000 hospitalization and 3,000 deaths. So foodborne illness isn't always just vomiting and diarrhea, but it can be much more severe. The global scope is somewhat corresponding with a total of 600 million estimated illnesses a year and 420,000 deaths. One really important fact here is that about 1/3 of these deaths are in children under 5. So this is a public health problem that some may argue is not as important as cancer or heart disease, but it has some serious implications globally, including for the young people in the world. Now, food safety isn't the only challenge. There are a number of related challenges that relate to sustainability of the food system. And one big one is food loss and food waste. Often we might conflate the two of them, but technically speaking, typically people differentiate between food loss, which occurs in the field, so at the producer level, or during the processing of the food, and then food waste, which occurs further downstream at a retailer, a food service provider or a consumer, which is essentially food that is being thrown out. Similar to the scope of foodborne illness, the scope of food waste is staggering. In the US alone, the estimate is that about 130 billion pounds of food loss occur, and that was in 2010. And you can see that food loss distributes pretty evenly across many food groups, with some of the highly perishable products, such as dairy and fruits and vegetables, being high on that list. But of course, these are also some of the products that are very important for the health benefits and are very important for nutrition. But also have been linked to foodborne illness, particularly if we think about vegetables and fruits. So these issues of food loss, food waste, food safety, introduction of foodborne pathogens, introduction of microbes or other conditions that affect food waste, food quality, and food safety is a systems problem. It starts often with the production, and sometimes even before the obvious production. This could be things such as the water used to fertilize or irrigate produce, through processing and distribution. But it doesn't stop there. It continues down where the food is presented, whether that's retail, home preparation, home consumption, but also in restaurants. So this is a challenge that affects the whole system. It's a classical systems challenge. The importance of food safety and the importance of food safety in a relationship to human health broadly is highlighted by the fact that it is part of at least 3 UN Sustainable Development Goals. Obviously, zero hunger is one of them, good health and well-being. And the third one is responsible consumption and production, which gets at the issues of reducing food waste and reducing the environmental impact of food production and processing, which obviously is large. So all of this combines to that many people think that food safety could be considered a wicked problem that is not open to a simple solution, and that probably never will have a final solution, which is why we published a series of articles, and it's why all of us here today and many others do research on using new tools and better approaches to continuously drive improvements in food safety but recognizing that zero risk is never really an option. And I think this is something we've all realized through our life. And Gareth started in the introduction. If you think about driving, we always make a decision that we will drive, even though we know it never will be zero risk. So this idea of having to make trade-offs and having to make decisions is inherent to human life and all activities that we conduct. So one of the challenges as we try to operationalize these new approaches to food safety and risk reduction is that we need to differentiate between hazard and risk, which very often in common knowledge and common words are used interchangeably. But technically speaking, a hazard is an inherent property of an agent or situation. So this might be Listeria monocytogenes, a type of foodborne pathogen, or it could be sharks, for argument's sake. A risk, on the other hand, is a probability, the probability of an adverse effect. So what is the likelihood of me getting sick if I eat a certain type of food that may be contaminated with low levels of a pathogen? What is the risk of me being attacked by a shark if I go swimming in one place versus another place? It's almost never zero, this risk. It can be extremely low, but a risk is quantitative. It's a probability, which, many people don't like math, makes it harder. We cannot use the two interchangeably. And if people get confused with the two of them, it will lead to negative consequences and reduced effectiveness in our efforts to improve food safety. And we'll get into that a little bit more. So what are some of these drawbacks of hazard-based food safety systems and hazards-based thinking? One of them that we commonly see practically is incorrect resource allocation. I may find the same hazard in two different locations. I might see a hazard in an animal, let's say a bobcat, that I see outside a produce field that may spend very little time in a produce field. And I might find the same hazard in water that is every day spread all over the produce. If I'm solely focused on hazards, I'm trying to control both of them. If I'm focused on controlling and reducing the risks, I will focus on water and realize that ignoring the one bobcat that might have E. coli in it is reasonable and actually helps us allocate resources where we have a bigger impact. And the same example also illustrates the suboptimal impact we can get with hazard-based thinking. We will allocate resources to places where we might have the hazard, but the risk might be extremely low. In addition, sometimes hazard-based thinking and hazard-based approaches get us to completely overlook key risks. We may find a hazard in one location, but the presence of this hazard represents a very, very small risk. On the other hand, we might have other locations in the food system where we have not identified that hazard, but that could be because of drawbacks in testing, difficulty in testing, but that other location, that other system might actually represent a higher risk. Think about, again, Listeria in a bobcat or E. coli in a bobcat and water where we're not detecting the pathogen, but we see that there are problems with the protection of the wells from pathogens in general or introduction of fecal material and so on. We have a hazard in one place. We don't have the hazard in the other place. However, the place where we don't find the hazard actually represents a larger risk ultimately for introducing foodborne pathogens. And that risk might be temporal. It might only happen in some certain specific times. It might not happen at the time when we test. So how do we get to risk-based approaches? We need to have metrics because we're talking about probability. When we talk about food safety, most people will initially think, well, it's easy. What's the likelihood of getting sick? But different illnesses come with different consequences. Some of them are vomiting for a day. Some of them are being in the hospital and dying. So we've come up with different metrics for this, which would be quality-adjusted life years, disability-adjusted life years, and so on, because they might better represent the public health impact. In addition, we can express risk with different denominators. We can express it on a per serving risk. What's my risk of getting sick if I eat a given food? These per serving risks can often be a little bit difficult to interpret, as illustrated by this table from a USDA FDA risk assessment because we see large numbers, 1 in 10 million risk, and we see large uncertainty that might go from 100,000 to bazillions, literally. So not easy to interpret, okay, but can be useful for some decision making. If we talk about public health decision making, we can express risk on a population basis. How many human illness cases due to listeria occur due to deli meats every year in the US? We can do a risk per 1 million people. That's different. It also accounts for consumption. If foods are consumed more often, obviously the total impact will be larger, even if the risk might be less. Lower in the given food, or contamination levels might be lower. So even a relatively safe food consumed a lot causes more diseases than a relatively less safe food consumed much less. And this is illustrated in this slide because often we hear about pasteurized milk, pasteurized dairy product versus unpasteurized dairy products. If we look at a risk as cases per year in the US, pasteurized milk could be estimated to be more risky because it causes more illness cases. However, if we look at the risk per serving, the risk for consuming unpasteurized milk is substantially higher, about 7 to 8-fold higher than it is for pasteurized product. So unpasteurized milk is less safe on a per serving basis, but pasteurized milk might cause more cases on a population basis simply because it's consumed more. Different metrics and help with different types of decision making. Now, when we talk about risks, there are business risks, as Gareth mentioned. We can measure them in different ways: risk of a recall, risk of an outbreak, etc. And we can consider this as we try to define what is a risk that we're willing to accept, or maybe tolerate is the better word, today. So with this, hopefully it come clear to all of you that zero risk in almost all cases is not an option. The risk will be there, it will be very small, but that leads us to the problem: which risk are we willing to accept, and how do we decide which risk are we willing to accept? This is an issue that's been associated with humanity for a long time. There's many articles about decision-making, about trade-off decision-making in different fields, whether it's finance or business, as shown here, or whether it's maybe more easily accessible in personal decision-making. If I pick a flight from one city to another, price is one driver, but the other one is how likely am I to miss my connection? Am I willing to take a connection? And so on. There's no right or wrong answer. It depends on what you want at this point in time. Are you willing to pay more money and have a lower risk of not driving in time, or you want to save money and it's willing to accept a higher risk? This is where it gets complex and difficult, and this is where some of the tools we will discuss and outline in our paper may help us to get there and define what risk we're willing to accept today and how we drive continuous improvement. So as we look into this multi-criteria decision-making with regard to food safety, which is what this really is, what do we need to consider? Food safety-related public health impact. How many people get sick? What are the downers? No-brainer. Sustainability, yeah. Emissions, impact on endangered species, etc. Clearly important. Impact on ecosystems. Food security. Sometimes easy to forget. If we have massive recalls, less food becomes available. Some people may not want to eat certain foods that they should consume, such as produce. How do we address that? And a host of other societal impacts. And this is not a comprehensive list, but a list that is meant to start us in this discussion as to how do we drive rational multi-criteria decision analysis related to food safety. So with this, I'll turn it back over to Gareth.
Great. Thank you very much indeed, Martin. That was so useful just to kind of get that all important definition sorted out between risk and hazard. And you set that out really nicely with some great examples there as well. And it's funny, it's one of those things that, maybe people are thinking, yeah, I know that. But actually, when you lay out what those differences are, that of course they're important, and I must admit I'm not sure if I'd have fully got them without you fully explaining them there. And of course we'll expand on that much more as we get into the discussion. Next we have Shreya Sunil, a researcher at Cornell University who specializes in microbial food safety and risk-based approaches to food system design. Now Shreya's work focuses on integrating quantitative risk assessment, data analytics, and sustainability considerations to better understand and manage foodborne hazards from farm to table. She studies how risk-based decision making can improve public health outcomes while reducing unintended consequences such as food waste and environmental burden. So very much a great way, Shreya, of picking up on what we've just heard there from Martin. Your work is, you're one of the authors on the paper, and your work is so relevant really to what Martin was saying. So you can shed a bit further light on this as well. So over to you, Shreya.
Thank you, Gareth. Hi, everyone. So today I'm going to talk about risk assessments, why we need them, how we conduct them, and how they could be used to do trade-off decision making. So during this presentation, I'm going to use the term Monte Carlo-based quantitative microbial risk assessments to refer to risk assessments. However, it's a mouthful, so I'm going to shorten it to MCQMRAs. So why do we need them? Well, as Martin already mentioned, the food system is incredibly complex. Before food reaches consumers, it can go through many different steps throughout a supply chain. And at each stage, there is the possibility that it could become contaminated with a foodborne pathogen. And once contaminated, the pathogen could either persist, grow, or spread in the food. Similarly, at some stages of the supply chain, we have an opportunity to reduce pathogen levels or presence, for example, with cooking of a product or pasteurizing a product. Now, the reason we need tools like MCQMRAs is that we need a quantitative way where we can account for how different stages within the supply chain can impact the final pathogen levels in a finished product at consumption, like the prevalence and the concentration of the pathogen in the product at consumption. And tools like this can help individuals make rational decisions about, for example, where they could invest their money to reduce like pathogen levels in the finished product and associated public health risks. Taking a very simple example of a supply chain of cooked meatballs, well, a processor could decide to maybe invest resources in increasing lethality of the cooking process, or they could invest resources in product formulation, for example, by including a growth inhibitor in the meatball to suppress pathogen and spoilage organism growth. So MCQMRA can help rationalize those sort of decisions. So now that we've discussed why we need them, how exactly would we conduct an MCQMRA? Well, I'm first going to talk about the steps involved in the QMRA part of it. We start off with hazard identification. For a given food product, what pathogen are we concerned about? This is something that we could answer perhaps by looking at outbreak data. For a given food, have there been previous outbreaks linked to a specific pathogen? And following that, we would conduct an exposure assessment. For a food of interest, what is the concentration of the pathogen and the prevalence of the pathogen in the product at consumption? The next step would be dose response modeling. And that is a model that accounts for, well, if an individual ingests a certain dose of a pathogen by eating contaminated food, what is the likelihood that they fall ill? And while I have listed dose response as the third step, it's important to note that it could sometimes happen at the same time as exposure assessment. Or also, typically, it's probably adapted from a pre-existing risk assessment model, because these models tend to be very few and far in between. The last step is risk characterization. In this step, we would look at consumption patterns of the given food in a population. For example, how many servings are consumed, what is the serving size, and using that data, along with the previous data in the QMRA, we could calculate the number of illnesses we may expect in a population within a given time frame, like a year. Now, the next step of a MCQMRA, or like another part of it, is the Monte Carlo simulation aspect of it. As you can imagine, QMRAs involve an incredible amount of data, and sometimes when data is not present, we would rely on assumptions made by expert opinion. However, Monte Carlo simulation is important because it allows us to account for the variability or the natural heterogeneity and uncertainty of the data, or like whether we have sufficient data to make the decisions that we're making. And instead of explaining how an MC simulation can help account for variability and uncertainty, I'm going to give you an example of why it's important that we account for variability and uncertainty. So we can look at two processes, process A and process B. Both of these, let's assume, are kill steps that cause a 5-log reduction of a given pathogen. However, they have very different standard deviations. And because of this difference in standard deviation, we can see that process A has a higher probability of having an insufficient log reduction, specifically a 10% chance that it would have a less than 4-log reduction. By comparison, process B, that has a smaller standard deviation, has a much lower chance of a non-compliant log reduction. It has a 1% chance of a less than 4-log reduction. And while this may illustrate why it's important to consider variability in a risk assessment, it also highlights something that's very important to understand, which is that risk interventions don't necessarily have to focus just on the main log reduction effect. For example, processors could achieve a better log reduction simply by reducing the variability in their process than trying to make it more lethal. So now moving on, even though we discussed a lot about what happens within MCQ-MRAs, it's important to note that they are just one part of a whole process called risk analysis. So the risk assessment allows us to predict or estimate the risk associated with a given food, and then also evaluate certain strategies that we could implement to reduce that risk. However, once we have conducted that work, that data is then passed on to risk managers who make the decision about which intervention may be applied or should be applied for the given food product. However, one limitation with this approach is that while risk assessments are based on very quantitative approaches, risk management may not necessarily apply the same quantitative approach and rigor to making their decisions. For example, selection of a food safety intervention doesn't simply depend on the achieved risk reduction, but it could also depend on more practical factors like the cost of implementing the intervention, whether it would have any environmental impacts, and whether it would have any indirect impacts to human health. Now, there have already been some approaches to making trade-off decisions in food safety, including not only for microbial risks, but also for chemical risks. And that I'm going to highlight one example, a study conducted by the FDA in 2014, where they evaluated the risk-benefit analysis of consuming of fish consumption by pregnant women on fetal neural development. It was an interesting study because they used two dose response models, one to account for the adverse effect of methyl mercury exposure, and the second to account for the nutritional benefits gained by eating fish. So by accounting for both the benefit and the cost, they concluded that the optimal amount of consumption, and they recommended that pregnant women should eat 2 servings of fish a week because that would maximize benefits such as nutrient gain without causing any noticeable adverse impacts. However, even with risk benefits, there's one limitation, which is that risks and benefits aren't only limited to the subject of the study, for example, the human population, but also to the planet and the environment. And this is where other tools like life cycle assessments and life cycle costing come into play. These are tools that, like risk assessments, will look at a certain process or product from the initiation of when the product is created through manufacturing, use, and finally until either the product is discarded or the process ends. And considering all those stages, it evaluates what resources are needed, energy, land, labor, and then also looks at the impacts. So, for example, greenhouse gas emissions, any other pollutants. By combining something like a life cycle assessment and a risk MCQ-MRA, we could holistically evaluate both the benefits and the costs of a food safety intervention. So I actually haven't found any examples where a hybrid MCQ-MRA and LCA has been applied to food safety, but actually I have seen a few examples where it's been applied for water management and water safety. So this is a study from Australia where the researchers were comparing two plans for water management that would maintain sufficient water levels in the Hawkesbury Nepean River and also provide sufficient drinking water to Sydney. Now, if we look at Plan 1, the river obtained water from a dam upstream and two wastewater plants. And at the same time, Sydney obtained water from that dam, but also from a desalination plant. By comparison, Plan 2, instead of having the desalination plant, there were actually 5 wastewater treatment plants that would be used compared to 2 in Plan 1. And some of that wastewater would be treated in a tertiary plant before being released into the dam, which would then provide water to both the river and the city. Now, if we look at the risk assessment portion of this study, we see that Plan 2 is preferable to Plan 1 because the researchers estimated that there would be roughly 0 dollies per year for Plan 2 due to foodborne illnesses, whereas Plan 1 would have 5 dollies. However, once we look at the results from the life cycle assessment, we see the opposite effect. Actually, Plan 2 has a greater number of dollies due to climate change, while Plan 1 has fewer dollies due to climate change. And when we consider the dollies from both sources, waterborne risks and climate change, Plan 1 is actually the better option. So this highlights why it's important to not only conduct risk assessments solely for food and water, but to also consider the range of impacts these interventions can have. So moving forward, I'm just briefly going to discuss future directions for trade-off decision-making. So broadly, AI can be used to enhance trade-off decision-making. It can help us do risk assessments faster. It can help us do in a more robust way. And then it can also help users interface with models, including non-technical users. However, even with trade-off decision makings, there's no guarantee we'd always make the optimal choice. For example, researchers have demonstrated that a phenomenon called satisficing, where people have a tendency to choose the first option that seems sufficient rather than the most optimal one. Thus, there are need for advances that can help make holistic and balanced decisions regarding food safety. And that's something our next speaker will discuss about AI-assisted risk negotiation. Thank you.
Okay, lovely. Shreya, thank you very much indeed. And of course, we'll pick up on that. And what a useful talk that was. And when you bring in the importance of considering the life cycle rather than just maybe a more cursory risk assessment. And you began by saying, yes, we talk about hazards, that is part of our decision making, but we take hazards, we combine data and statistics around, kind of aspects around hazards, but we identify hazards. Yeah, sure, they're important, but then you have to take into account exposure and lots of other things. So you start with hazard, but then end up with risk, and that's where useful things happen. And I really got that from your talk, Shreya. Thank you very much. Finally, in this introductory section, I'm very glad to welcome Professor Sophia Joller, Chair of Food Microbiology at the Ludwig Maximilian University of Munich. Now, Sophia's research focuses on foodborne intoxications and toxico-infections. Sophia is particularly interested in host pathogen matrix interactions and characterizing and quantifying biological molecules to understand structure and function. She's using AI-driven approaches to improve risk assessment, management, and communication of foodborne risks. Sophia contributes richly to the field through both her research and indeed leadership roles, including serving as president of the Swiss Society for Food Hygiene and as board member and secretary of the European College of Veterinary Public Health. She's an editor for the Federation of European Microbiological Societies Microbiology Letters and for Frontiers in Microbiology with us. She's also editor-in-chief of the International Journal of Food Microbiology. So, Sophia, you're very busy as well. Welcome along. Good to see you. Please pick up the discussion for us, won't you?
So I'm very happy to be able to pick up where Shreya and Martin started, and to move into an area where we can now have an example of how we can leverage AI-based tools to have a new understanding of risk analysis and to incorporate trade-offs. And I want to start this off with graphics that you might already have seen. If you didn't, please check it out. It's fantastic work by Rockström and colleagues that was published in Lancet. And you can see here that they identified 9 critical Earth system processes that we need for the resilience and for the stability of our planet. And the green area is an area where self-regulation is safely possible. And once these systems transgress into the orange area, we do not actually know what will happen to the planet. So here you can see that some of these would be freshwater change, land system change, and others. And food systems are amongst the most important drivers for the transgression of these boundaries. 5 of the 9 boundaries that are transgressed are mainly driven by our food systems. And we also do know that our food systems account for roughly 30% of the total greenhouse gas emissions globally. So we have to consider if we can produce and use food differently to protect the planet. In our manuscript, we have shown this graphic that tries to show that whenever there's a trade-off between systems, such as human health and environmental health or animal health, you have to really look at how you protect the goal you want to achieve without interfering with another sector. So, for example, if you have an intervention that is targeted at safeguarding a consumer, you might at the same time have unintended consequences for the environment or for animal health. And One Health would be the framework that allows you to look at these components jointly. And that was the basis of our work that I presented today. So we were wondering how we can move towards an integrated risk analysis that balances trade-offs such as food safety, food security, and sustainability. If you live in a country where food security is not a given, food safety might become a secondary issue to you. So you really have to look at the context here. And I also have to say what we developed is not only applicable for looking at these trade-offs, but you could also look at trade-offs such as economic interests versus consumer interests versus food safety versus cultural aspects. This is not exclusively my work, of course, but it's a work of love by a large consortium of wonderful colleagues that I'm very lucky to be leading. It's called the MICRIS Consortium, and we're funded by the Swiss National Science Foundation. And this is a team of colleagues that have dedicated so much of their time, often for no financial gain, that come from very different areas. Jakob Zinstag is one of the founders of the One Health concept. We have people that come from the food safety regulatory side. We have a mathematics professor, we have environmentalists, we have food safety experts, and we also do have representatives of the industry. And together we have jointly coined a term called risk negotiation. This is a framework that we suggest as a possible approach on how to do a risk analysis in a way that allows for incorporation of trade-offs. And it's very much building on the traditional Codex Alimentarius setup that Shreya showed earlier. So a setup where you have the 3 pillars of risk assessment, risk management, and risk communication. So this is unchanged. This is working well, and we do not want to interfere with that. What we suggest is that we leverage the technological advances that we have seen in just the last 2 or 3 years and incorporate a stakeholder roundtable, a 4th pillar, that allows us to look at the trade-offs across sectors in a more integrated fashion, and that also allows us to integrate large data, for example. So if we want to see what that means, it's an iterative 6-step process that would start with looking at a problem and identifying who is affected, who are the stakeholders, if you want to look at this problem. And with these, you would find representatives for a stakeholder roundtable to negotiate this issue. You would jointly formulate the problem and then move towards a risk assessment and valuation. The valuation is really important. So whenever you can put, let's call it a price tag to what you're doing here, to the scenarios you're looking at, then this is really helpful to move towards a consensus. If one side is saying we want to protect the biosphere and the other is saying I want to protect human life, It's very different to play tug of war and arrive at a middle ground if you're trying to express that in some sort of quantitative way, where you say, I'm looking at disability adjusted life years, I'm looking at dollars, I'm looking at something I can quantify. Then we can start to have a very palpable discussion moving towards something that is close to solution. Then the fourth step is the core of what we want to introduce. That is the actual risk negotiation. We're going to look at that in a second. And the decision. And here, the decision is not done by an AI tool. It's done by the stakeholders. It's a human in the loop approach. Once a decision has been reached, the stakeholders will go back to the groups they're representing, communicate what they have negotiated, and you would move towards implementation. And we think that at the sixth step, it would be really, really important that after a certain agreed time frame, there would be an outcome evaluation and a risk renegotiation. So what does it look like? Let's look mainly at the risk negotiation, because that's the part that is really new. Here, what would happen is that you have stakeholders. Let's have three different ones here. For example, a consumer, a farmer, and the food safety authority. And each one of those has their preferences, and they will not be identical. They will move into different areas. What will happen as a next step is that each of these stakeholders can inform a large language model. Some people, when discussing with me, have asked me if that's an avatar. If it helps, then you can call it an avatar. It's a large language model or a personalized ChatGPT or Mistral, whatever you like to use, that would argue in your place. You can design it. You can say, this is my belief system. This is what I want to achieve. This is what's important to me. That's the data I want to have, you know, as a basis of my discussion, but that's basically me. And then the beauty is that these large language models start to argue with each other. They negotiate. They have this tug of war of trying to make the other one move a little bit towards your own goals. And in contrast to humans, they don't get angry, they don't get tired, they don't get hungry. They don't have a problem with you because you said something against vaccinations or pro-vaccinations or whatever. They are just neutral, and they will discuss in your favor as long as it takes, which is far more than you can say for humans. So it takes a lot of hostility out of the picture. If you imagine a large developing company having to argue with the environmental side, you really just look at the content. You don't look at the past, the emotions behind it, and so on. The large language models will then arrive at a consensus, or let's say a deal, a final deal. And this is a combination of interventions. You get this, I get this, and this is our final deal. We reiterate that for 50 to 100 times and see if it always comes to the same solution. Often there can be different solutions. And then this outcome is shown to the humans at the table to let them see where there's an area of likely consensus for a deal and where we're really far away from it. So it informs the discussion that takes place amongst the humans. You arrive at an equilibrium distribution based on the LLMs, but this is not the final deal. The humans come in and say, the final deal has to be a little bit different because I cannot live with this or that. So you just use it as an informed basis for your human discussion. Anna Allende and Sarah Bowe-Seed wrote it beautifully in their article accompanying our lead article, and they said, risk negotiation emerges as a necessary evolution of food safety governance. Risk negotiation does not imply compromise without rigor. Rather, it refers to a structured, evidence-based process that makes trade-offs explicit and accessible. By integrating predictive modeling with trade-off risk assessment, the framework supports decision-making under complexity and uncertainty. And I think that's the beauty here. We have something that helps us navigate the increasing complexity that we have to deal with when answering the big questions in food safety and looking at these trade-offs. And just as a final word, I really want to acknowledge not just the PIs and all the senior people that have worked on this, but also the young scientists that have been fantastic and poured so much blood, sweat, and tears into that work. And without our physicists and all the others, we would not have been able to make it work. So thank you so much.
Great. Thank you as well, Sophia. Really thought-provoking and so interesting to hear about the role that LLMs can play in this and that kind of adversarial approach where they kind of, in inverted commas, argue it out and lead to, some kind of guidance for the humans. And you really stress that it's the humans, they are in the loop. That's what matters. But we can take the
Yeah.
best of the AI with, the all-important human factors and come up with more rational outcomes. So thank you very much for that. Right. It's panel discussion o'clock now, and I think we should say hello to our first guest panelist, Steve Wern, OBE. Steve is an expert in food safety with over 35 years in national and international food policy, during which he's helped harmonise EU legislation on food additives. He went on to work on regulations relating to food contaminants and veterinary residues. Steve's held all kinds of senior roles, including at the UK Food Standards Agency, and he's played a leading role in shaping global food standards as chairperson of the Codex Alimentarius Commission from 2021 to 2024. Then in 2025, he was honoured as an Officer of the Order of the British Empire. That's an OBE for services to public health and food safety. So let's start with well, in fact, I'll tell you what, before we jump in with you, Steve, I want to introduce Frank as well. Let's do that. Frank Yanis is also with us, former Deputy Commissioner of Food Policy and Response at the US Food and Drug Administration, and he's a past president of the International Association for Food Protection. And Frank is a globally recognised leader in food safety with extensive experience in retail and public health. He's widely known for advancing the concept of food safety culture and applying behavioural science to improve compliance. As former Vice President of Food Safety at Walmart, see, I told you he knows a bit about this. He was at Walmart. He oversaw food safety and public health functions for the world's largest retailer. He's received numerous honours, including from the FDA and National Sanitation Foundation. He's also past president of the International Association for Food Protection. So there you go, folks. You know that you're in good company with these two. And of course, the rest of our panel. So, Steve, let's start with you. And your policy outlook argues that, there's this whole idea of binary compliance. Foods are either completely safe or they're completely unsafe. And you're calling for something a bit more nuanced, like a broader transformation. So what do you make then? You've had a good look at the lead article, and there's this talk of trade-off risk assessment, as we've been hearing from our speakers just now. It seems like a more rational way forward to me. What do you make of it?
I think it is, because scientific reality tells us that all foods inherently carry some residual risk. But there is this societal and regulatory pressure for us all to collude in what one of the other authors of the article calls a zero risk illusion. And problems then emerge for regulators, for international trade, when that expectation of zero risk is overlaid on the health-based values we use in standards for trade and domestic food supply, such as maximum limits of contaminants in food. Because those are regulatory compliance limits, they're not food safety limits per se. But they are perceived as that cliff edge. As you say, foods with levels of contaminants below those limits are seen as safe. They're allowed to circulate freely. Food with levels of contaminants above those compliance limits, even marginally above, are seen as unsafe. They're excluded from international trade, often regardless of the implications of profligate food waste on national and global food security. So what trade-off risk assessment would give us is the opportunity to break away from that zero risk illusion. It gives us the opportunity to recognise and reward, for example, the large proportion of potential public health benefit from food safety improvements in low and middle income countries that can be gained through efforts that improve food standards enormously, but not quite to levels that meet those of international standards. And that happens all the time in a wide range of settings. It would help us to find appropriate markets for those products, and it would build incentives for public investment and for donor country investment in food safety in some of those most challenged settings.
All right, yeah, no, it's really important. So let's bring Frank in here as well then. And of course, Frank, coming back to the lead article, as we've just been discussing there, it argues that we're kind of looking the wrong way if we're obsessing over this whole idea of zero detection, because then we end up diverting resources away from more significant threats. So you've had this senior food safety role at Walmart. So wearing that hat, is sufficiently safe really safe enough? And we are talking about the health and well-being of millions of people. The stakes are high here, aren't they? It's important we
Yeah.
get these calls right, isn't it?
Yeah, it's very critical. Thank you, Gareth. First of all, let me thank the conference organizers and the authors for actually putting this forth, because I've been emphasizing that we need to continue to evolve our food safety management and risk management approaches. If you think about it, HACCP was born in the 1960s. It is the primary model that food safety professionals get trained on around the world and use to try to manage food safety risk, HACCP. And what does HACCP stand for? Hazards, not risks. I think we haven't done a well enough job on really drawing the distinction between hazards and risks, and this article is forcing a larger conversation. So thank you for that. Just a quick comment on this zero detect and transitioning to sufficiently safe. I just want to make sure that we understand that zero detect, we're really focusing on hazard. There's two sides to that coin, right? If you detect the hazard, what we're proposing or discussing today, that might not be a risk. It might be that you found something, you really understand why the detection occurred. You need to understand routes and sources of contamination. Does it exist elsewhere? Are there other pathogens or risks in your food system that are higher? And so this article and this webinar has made the case, which is maybe that leads us astray. But I also want the audience to know that it can also give you a false sense of security, because we're so focused on trying to detect. Just because you don't detect doesn't mean there isn't a hazard and risk present. And the example that I use a lot, having been through the infant formula crisis in the United States, you use an N30 sampling plan, N30 at 10 grams a piece, you test 300 grams of a 40,000 pound production run, your probability of detection is very low. And so let's just make sure we understand both sides of the zero detect equation. But what do we have to do to transition? Because I am in favor of transitioning, and I think there's a couple of things we need to do. One is, how do we talk about it? And Gareth, you made a nice job. Is sufficiently safe? How consumers react? I would suggest that we need to be very intentional on the language that we use, because sufficiently safe to me sounds a little vague, and it sounds like complacency. And so I think we need to be intentional in the adoption of language. And I've written down some terms here like meet scientific standards, or it's scientifically validated. But I would avoid saying sufficiently safe, because who's going to make that decision? I could say, hey, in the United States, there are 150 million servings of fresh leafy greens consumed safely every day. But say that to the parent who lost a loved one because their child ate a contaminated salad. Is that sufficiently safe?
That's the thing. And, because I work in the media, so the good old media, it's going to put a big headline front pages, that poor child who was injured or harmed or, God forbid, died from eating an infected or contaminated salad. That's front page news. The,
Right.
2 billion other children who just had a meal and they were fine. That's just not news, is it?
It doesn't work. So I think, intentional on the words that we use, and the concept is right, audience. I just think we need to be intentional on what we describe it. I think another thing we need to do to make this transition happen is start educating current and the next generation of professionals. So we know we have some academicians here, but we need to evolve HACCP. It can't be the traditional HACCP model, Martin, that we've used for 60 years. And we need to start incorporating better concepts of risk management and how people are supposed to do this. I know it's easy when you get a panel of experts and you give them 2 years to do a risk assessment, but how does a manager do this on the plant floor? And then the third thing I would just say is we need to bring all stakeholders along, because it's fine for a group of hardcore food safety professionals like us getting together and doing this, but we understand that we're living in the era of a global trust bust. And so we need to bring the consumer groups along, academicians, regulators along, that we're going to this is an evolution. This is modernizing how we manage food safety risk.
Yeah, it's a big deal, isn't it? Okay, well, let's take some of that challenge to Martin, because a lot of what you said there, Frank, is brilliant and really provocative, and we like that. So, Martin, let's put you on the spot. Where did sufficiently safe come from? And is it a good term? Do you stand by it?
I'm not. I think it's the sufficiently safe. It's been around. I've heard. I think maybe it was even Steve. I heard it. I think in maybe Codex or WHO. Some people. I think maybe it was on a speaker on WHO at some point that was very intentional about not saying this food is safe, but calling it sufficiently safe. But I totally agree with Frank. Words and how we present these things are gonna be super important, right? Even like we used to, we move towards tolerable risk versus acceptable risk. Because the thing about the part of writing this article, someone's like, don't use acceptable risk because no one's accepting really any risk. And it sounds like, again, that sort of complacency part, and we need to choose the words that it doesn't look like we're trying to preach complacency or support complacency. And also, I think sometimes people think when we talk about risk-based that it's an excuse to allow industry to not spend all the money they should be spending on food safety. So words matter, and I think this is going to be the next level of discussion. How do we socialize this and get acceptance? And I think you pointed out the other point that's really important. It's one person dies. How do we address that? And I'm trying to look at other areas. So that's car, traffic accidents, airline accidents, etc. Because this is not a unique food safety issue. But
Yeah.
words matter. I think, Ms. Frank, we need to work on that. That is on
Yeah.
the to-do list, high on the to-do list.
Yeah, no, sure. No, I think if I was on a plane and, the captain came and saying, well, we're glad to say that the flight today is sufficiently safe. I don't know if I feel that I'm not sure if it can really persuade me, but yeah, no, fair enough. No, so it's really good to get us into the discussion there. So Shreya, let's come back to you then. And I was really fascinated. I thought you had that great example from water safety, looking at that case study from Sydney. And so I'm interested in how we can incorporate ideas. I think Martin's suggested that we can and should be doing that, looking at other sectors and indeed influencing other sectors. So you mentioned water safety, but for instance, can we look at examples from aviation? That seems to be quite a good one because, millions of people fly, there's no such thing as a 100% safe airliner, is there? But flying is, well, sufficiently safe. I'm using that phrase.
Yeah, absolutely. So we have one example from water safety and water management, but in addition to that, one field in particular that's had a lot of trade-off decision making is natural disaster management, or particularly any type of disaster management or avoiding disasters. So for example, with disasters, you have like very high stakes, you have high potential for loss of life, but then with false calls, like for example, if evacuation orders are released and actually the hazard or the disaster doesn't end up being that severe, you have economic losses, you have things that can disrupt people's everyday life. So those fields, particularly, we have cited some examples in our paper where they've used trade-off decision making. And they actually utilize approaches we could also use. So it would be approaches like risk-benefit analyses. And also, I believe one study did combine something like a life cycle assessment with a hazard analysis. So
Yeah,
that's the
okay.
thing I can think of off the top of my
Yeah,
head.
no, it's a really, really good example. And Sophia, I just want to come back to what you were saying, using the large language models. And I think it's technically correct to call it an adversarial model, isn't it? So they do the arguing, so the humans don't have to. And they'll go at it and they won't get all emotional and so on. And that sounds great, Sophia. But the inevitable question is, of course, as we all know, these LLMs have biases too. And they're actually quite human because we're the ones
Yeah.
they're based on our data, aren't they? How do we get around that?
So for us, it's the human in the loop approach. We always have the stakeholder table where the in-field experts act as a decision and control body. So if they see that there's something coming up that doesn't make sense to them, this would be the time where the in-field expert steps up and says, this is not correct. I don't want anything to go into that area. Also, just as lessons learned from running that with different scenarios and different use cases, we saw that you could program it in a way that leads to deception. You could make it manipulative. It's part of the design, how you want to run it. What we have done is to make it fully transparent so that each of the stakeholders could read the whole discussion in the end of the large language models. It's just a conversation that you can read. To also have a moderator that looks at the whole process and tries to safeguard how it's running, and to also try to incorporate, for example, a RAG system where you have trusted information that you input and that you allow the system to draw from. And if you do that, you have a far better outcome in terms of making it trustworthy.
Yeah. Okay. Lovely. Thank you. So we're going to go to some audience questions now, and we'll continue to do that really right up until the end of this, sort of 25 minutes or so of discussion that we have. Steve, I'm going to bring you in first because just we haven't heard from you for a while, but then the rest of you, you just pile on in, won't you? So let's start with Steve first, though. You have the mic. Ricardo asks, are risk managers prepared to interpret the outputs of such risk assessment approaches? If not, which elements of the risk assessment outputs require capacity building or training? Where are the deficits then, Steve?
Well, it's good that we're talking about risk managers. That's the role that I had for all of my career. And risk managers and decision makers, I mean, it's entirely legitimate for them to take account of social, environmental, and other factors, costs, and benefits when making decisions on the optimum interventions for food safety. And actually, those trade-offs are made all of the time by decision makers. It's just that they're very rarely made transparently. And I think that's one of the advantages of this new system. It's bringing those decisions and consideration and factors into the light, explaining them, and allowing other segments of society to participate. So I think that's the key for me. It's making decisions that, by design, are more socially robust rather than just being taken by one person in isolation who may have a weighting of different factors that is really different from everybody else's. So the social robustness of decisions from risk negotiation is something that I'm particularly interested in.
Yeah, no, absolutely. Amelia asks, see, just put your hand up if you want to take this, anybody. What are the key food safety risks when reusing food byproducts? That's a good question. And then how can a risk-based approach ensure these practices remain safe and sustainable? So Amelia's moving it onto those byproducts there. Who wants to take that?
I can start us out. I mean, I think it's real, the example Shreya brought about, water sources for Sydney gets into this point because it has water retreated, and I think reused water is a huge one. Post-consumer recycled waste. This is a huge challenge where we have right now very few risk assessments. But I think we got to look at environmental impact and impact on food safety. DALYs might be a good sort of a metric for comparing that. Where do we have a higher risk, and do the benefits of reusing outweigh the risks? But I think the unknown then becomes, DALYs are okay, but what if, let's say, we don't reuse certain or recycle certain food packaging, whatever it may be? It's the impact on ecosystems. We cannot, it's not as easy to adjust DALYs to that as it might be to climate change. So I think finding these metrics can be a challenge in some of that, but I do think it's a big area. And I think the example Shreya brought up could be applied to that life cycle analysis plus risk assessment.
Yeah, okay. Because Shreya, you were the one who brought DALYs in, weren't you, as well? So did you agree with that, Martin? With what Martin's just been saying there about, we just got to be a bit careful about what DALYs we use.
Yeah, absolutely. So, for example, DALYs, we can use it to assess the risk of illness, so like the burden of illness. However, when you look at other systems, a DALY might not be the most appropriate risk metric. So, for example, with the study I cited about water management, for them to be able to have a uniform metric, they had to actually make some assumptions from the life cycle analyses that were perhaps a bit based more on assumption than data. So having the appropriate metric for the appropriate use case is useful. And
Yeah.
even if we manage to get one unified metric, there's also the issue of risk perception. For example, someone may weigh a DALY, for example, that's lost due to foodborne illness differently than a DALY that's caused by food waste. Like people may prefer to avoid the DALY of an illness or death compared to maybe we tossed out a few packages of spinach.
Yeah, so not all DALYs are equal. Steve, you had your hand up.
Yeah, just to come in briefly, because I think this is a really practical question. There are some very practical discussions going on in international fora around water that's safe enough, if you like, and fit for purpose. So moving away from the concept that whenever water is used, in or around food production, it needs to be of drinking water quality, towards a sense that water needs to be fit for purpose, and trying to define the microbiological and other safety criteria for water in different applications, because we know that water is becoming, particularly in many countries, a much scarcer resource. Also in recycled plastics. We know that we're all being driven to use more recycled materials and to recycle household waste. But how can we make sure that recycled plastic is safe enough to be used in food packaging and come into contact with the food we eat? How do we make sure it's collected safely and processed safely? So those are some really practical discussions that are going on. It's a really well-placed question because those are the discussions that are happening right now. Back to you.
Yeah. Frank, you got your hand up.
Yeah, I just wanted to add because it's a great question, and you see how it's led onto different dimensions of it. And to me, what it makes me think of is that we are moving towards a world where we're going to be very focused on a circular economy. We're going to try to minimize waste, whether it's water, whether it's packaging, whether it's, products. And and that means it's a world where there are going to be risks that we've never seen before. And so the question or the challenge really is to make sure that good food safety risk managers have a seat at the table as we try to do things that we've never done before in the history of the planet. And what I've seen in some outbreaks that have happened, sometimes we have the wrong people making those determinations. We might have a microbiologist doing the risk assessment when the hazard and risk might be a chemical hazard. And so we just need to make sure that we have the right people at the table.
Backgrounds, different lived experience, and so on. So, yeah, no. Can I just ask? Here's one from Thamim. He takes us back to AI and asks, how can AI-driven real-time monitoring systems be integrated into existing food safety management frameworks to dynamically balance microbial or any other risk reduction with sustainability goals, such as minimizing food waste or optimizing resource use, without overburdening industry operators? So it feels like one to you, Sophia, but I'm really up for the panel just
I
jumping
can
in. Let's
start
try
us off.
Sophia first. Yeah.
The one at the forefront of my mind at the moment is that once you have real-time AI-supported solutions to monitor your production, you can, for example, distribute streams if you're big enough. You might not want to use something in infant formula that you judge not sufficiently safe for infant formula, but you might be able to use it for something else. So if you're big enough, this can be interesting. If you're large enough, you might also be able to bring those let's say produce or whatever you're handling that did not meet a certain specification to a plant that can handle them at a higher hygienic level. That sometimes can be interesting, but it is not as easy if you're smaller. It's not as easy if you don't have that wiggle room, or if you're dealing with something that you need in an amount and where you cannot switch to a different producer, for example. So it's not a straightforward answer depending on your personal circumstances of that production, I would say.
Yeah, Martin.
Some other examples that are applicable that I've seen is, for example, you could use video surveillance and cameras to see, did sanitation happen? And you're at a level of sophistication with image analysis that you can say, hey, this pallet, this spot should be sanitized every hour. It was not. And you get a real-time alert to your cell phone that some task was not performed. You can get real-time alerts that vibration on a piece of equipment is different than that we have past data that suggest that with this level of vibration, your risk of contamination goes up. So there are different feeds of real-time data that can help us with decision-making and reduce risks. However, point of caution is these are expensive investments or investments at some level. And at some point, the question does become, is the question of opportunity cost, right? If we invest $100,000 in AI, does that have the biggest return on investment for food safety? Or is it hiring 2 people on the 3rd shift to do sanitation? And I think these assessments do also need to happen, because I think that's with all technologies. We need to make sure we appropriately use it and keep in mind the end goal.
Frank.
Yeah, Gareth, if I could weigh in on this one, because I am very bullish on the role AI could play to strengthen food safety, and to the topic of today's conversation about better assessing risk and risk assessments. But there are a lot of use cases. I think you start with your use case. The use case might be AI is very good at prediction. machine learning, an early version of it, but advanced versions. It's good at monitoring, as Martin said, but you have to pick your use case. You probably start small, Martin, and you don't try to boil the ocean. But I just want to fundamentally let the audience know that it's going to be a game changer. We're very early in the days of AI. We're at day zero. And fundamentally, what we've always said is we want data, and we want food safety data, which we've generally captured on paper. Increasingly, we're capturing it in digital form, and we want to convert it to information. What AI does, it converts data to information differently and more effectively than the old statistical tools that we used. And it can use data in 3 or 4 or 100 dimensions. And rather than just convert food safety data into information, it can help us learn new information. But I think, Martin, we'll find a day when we can actually use AI tools to do better risk assessments. The question is going to be, Sophia, is whose tool and whose model do we use, and how do we trust it, and will the regulators validate it? So we are going to reach a day, and we need to start thinking about that right now, is how do we validate these tools? But I think it'll allow us to do risk assessments, Shreya, a little differently. We do risk assessments today based on historical findings. These are the pathogens or the chemicals we found in products in the past. It'll allow us to do them a little bit more forward-looking. Well, maybe CBOT and powdered information should be something, because the literature and data is already suggesting some signals or trends in other parts of the world.
Yeah. Okay. So just briefly, Sophie, on AI, and I think Martin had a comment as well. So just really brief comments from both of you, and I'm going to move on to governance then.
Just very briefly, I love that you brought that up, Frank. And I think it's crucial that we have a central standard for model repositories, for example, so that we know that what we use is trustworthy and it's comparable to the standard that we want to achieve.
Yeah, lovely and brief. Martin, do you have something to say on that, or?
Yeah, so I think the other thing, to Frank's point, I think doing risk assessments more efficiently is the short-term view already there. Where right now, most of the risk assessments are not accessible to most people. It takes tremendous expertise and time. With AI, you can run some of these risk assessments if you have the standardized repositories that Sophia mentioned in a matter of days or hours. And I think that's a tremendous opportunity too in that space.
Yeah, no, I agree. So let's talk a bit about governance, because quite a few questions coming in on that. Soumya asks, can you provide an example, like any of you, where a trade-off between food safety and sustainability led to a change in policy or practice? So I'm going to put it even more bluntly. Is industry really listening to all these academics? Who wants to take that on? An academic or an industry person can take that on. I'm fine.
I'll start.
I can get us. Okay, go ahead, Steve.
I'll start with one example from international standard setting where a balance was struck, not between food safety and sustainability, but interestingly, between food safety and food security, when a different standard was set for aflatoxins, which are contaminants in cereal-based foods for children, for food aid, than for food in the regular food supply. And the level for food aid was higher. And you might think, well, that's a bit perverse because they're very vulnerable people and we want to be protecting them. But you actually have to remember that risk assessment for food is about exposure as well. And we normally set levels presuming that a food can be safe for a lifetime exposure, but food aid is designed for very short intervals of weeks or months. And so you can afford to set limits that are not quite as prescriptive, knowing that what that means is that the food can then flow more freely to those most vulnerable and most needed populations. And that was a move that was supported by UNICEF and the World Food Programme and Médecins Sans Frontières. So I think from my experience in Codex, that's the only one I can think of where we've had an explicit trade-off between food safety and, in this case, food security. Back to you.
Yeah, that's great, Stephen. And did that set a kind of precedent, or is it likely to? Or I suppose that was your point.
It's not happened again since, and it was very contentious at the time, but I hope we've learned from it.
Yeah, no, absolutely. And so those of you in the academic community, which is most of you on the panel, really, how much are you sort of talking to industry around all this and policy makers? I mean, I know it comes with the job. You talk to different stakeholders all the time. You go to high-level meetings in Davos and goodness knows where else. But what is that dialogue like? And you can be honest.
I think I'm going to answer your question, but I think that the trade-offs between food safety and sustainability is happening every day in industry. but not with the transparency that Stephen mentioned. Everyone in a company is going to make a decision. This happened. There's a very small increase in food safety risk, but am I gonna, scratch that whole production batch? And it's sustainability from an environmental perspective, but also business sustainability. What we're proposing in these systems we're talking about will make these trade-off decisions more rational and more transparent, and therefore hopefully better. So, and that gets to your second question. When we talk to industry, absolutely, we have these conversations. I think the real challenge is that the overall legal environment, and the fear is that if you are seen as even putting into writing or anything that you say you're accepting X risk for your product, no one is willing to do that, and very few people are willing to do it, because you might say, I'm willing to accept one illness per year or per 10 years in order to increase or reduce environmental impact. And I think that can be an exposure to legal challenges that many companies are not willing to take. That's the US situation, okay? And I would love to hear what Sophia has to say, or Steve, how that is in the rest of the world. But that's where we are right now when we talk to industry.
Yeah, I can maybe add something for Europe. We had EFSA as part of our sounding board for the MICRIS project. And one of the people that came up with risk negotiation as a key figure is Kostas Koutsoummanis, who was the biohazard panel lead for many, many years. So we do have a very close link to the European Food Safety Authority. And also, once the risk negotiation manuscript was out, we were contacted by the IRAC of EPA and FDA and so on. And so we are having these discussions on how to employ the system. And there's a lot of interest. The question is, how can we implement it in a way that builds on what's currently there? But there's a tremendous amount of openness that I honestly did not expect. And especially in the industry, as we do see that there are a lot of these decisions that need to be made, and people want to have a basis for their decision making.
Okay, so we've got about another 5 minutes left. Let's take, where should we go now? Yeah, there's a good one here from Sandipta asking how research can be conducted to integrate both of these fields, which presumably means either food safety and sustainability. What research approaches, continues Sandipta, are needed to effectively integrate One Health principles into risk-based food systems? Dear panel, I'm slightly looking at you, Shreya, but any of you can take this.
Well, I think the biggest thing is that all of these research projects that look at like broader impacts and holistic effects can't only be done in one discipline or by one individual or by one research group. So it's really important when we start to address these questions from many different perspectives, food safety risk, environmental impact, and so on, we involve teams that have researchers from many different disciplines. And I think that's one of the biggest issues that I think in terms of at least also training individuals, myself and others, being able to use different tools and work with people from different disciplines.
Okay, yeah, absolutely.
I think more research needs to be done in the field. I think that's also the challenge we need to, because some of these inputs we can only get the right data if we do research in real systems and in diverse systems. Second one, I think is really important that we quantify variability and uncertainty, because that also becomes very important in decision making. So variability is how different can an organism behave. Uncertainty is just how much knowledge are we missing? How sure are we that this is what's really happening? And if we take more measurements, we can reduce uncertainty. And I think those are going to be two really important parts: variability and uncertainty in the real world, and then bringing that back into the computational law.
Okay, and I think we've got a really deep and brilliant question here from Bettel. I think this will take us to the end of the discussion, actually, because I think I'm going to ask all of you this. We have strong science, growing policy attention, and increasing public awareness, says Bettel. So why do preventable food safety risks still persist at scale? And who in this ecosystem needs to change behavior first? Scientists, regulators, or industry? In fact, I've only got a minute for this, so I might just have to have a couple of you on this.
May I start us off?
Go on then, Sophia. You can.
I think all of us. It cannot be
yeah.
someone has to do this. This has to be all of us in sync together jointly. Otherwise, we cannot make it happen. We need all of these different aspects.
Yeah. Well, that was lovely and brief. So yeah, who else wants to comment on that?
Uh,
Who's taking this on?
I'll
Who
have a
should be?
go. I think we have a
Yes.
shared responsibility to drive it up the agenda of every place where this is discussed in research, in international standard setting, in UN agencies. Um, it all needs to happen together, but it won't happen until we start forming this agenda in those places.
All right. Which cues us up very nicely, actually, to kind of move to the end, and I'm going to give each of you a minute, no more, to give us your big thought that you want people to take away with this, that really big important thing that you're hoping I was going to ask you and I didn't. This is your chance. So, what's the last thing you want people to hear you say on this subject? Let's see, who's not spoken for a while? Martin, I'm going to put you on the spot, I think. Yeah, let's do that. Martin, your final thought.
I think the final thought's important for everyone. We're not asking for them to change completely. This is add transparency, add vigor, and do something we've always done intuitively and just do it better, but then implement it broadly, as we just said. We got to all work on that together.
We need the implementation, says Martin in conclusion. Shreya, what's your big, important, massive thought we should take away?
Yeah, so I absolutely agree with Martin. I think the big thing to think about is that all these decisions have trade-offs and no decision is zero risk. So one really big thing is that maybe formally being able to make those decisions in a quantitative manner that's transparent would be important.
Okay, so yeah, quantitative matters there, along with the qualitative, of course, as I know you would say. Frank, big important point.
Yeah, great. One of those last questions was why do we continue to see outbreaks? The incidence of foodborne disease in our country hasn't changed in over 20 years. So why is that? I think today's conversation, we need to do a better job of identifying risks as opposed to hazard. If we do a better job with the risk assessments, we are halfway there. The other takeaway I'd say, which has been part of today's conversation, it's lacked, is, and then make sure you implement a very effective control to manage that risk. Because it's one thing to identify the risk, but you have to manage or control it.
Yeah. Sophia.
For me, it's make it participatory. Talk to other stakeholders. Don't just stay in your lane because you will not fully grasp the problem and not find the best solution.
Yeah. Okay. Steve, final thought from you?
Thanks. I mean, we've spoken a lot about AI-driven food safety decisions, and as Frank said, we're at day zero, and much of this is in the future, us looking forward. But it would be wrong, I suggest, to just wait for that day to come because before we have those models, we can just talk about it, as Sophia said. Don't stay in your lane. Talk to other people. It's 5 years now since the UN Food Systems Summit, and we really need to start making some of those linkages that will allow us to transform food systems and deliver food safety and food security and sustainability together.
Yeah, and just in our final few seconds then of this section, Martin, we've got time to come back to you because you're the lead author on this article. So, what do you hope the article will achieve? Who's your main audience for this article?
I think part of it is what we did today. I think a more robust, deeper discussion. I think the audience is really everyone. It is industry, it is government, regulators. But I do think to a certain extent, regulators, Codex, they need to give us a signal and lead us in this because it's going to be very hard to do this for individual companies.
Yeah, and I have when we've spoken about so many different aspects today, and this talk about bringing in the life cycle analysis as well as starting with the hazard life cycle analysis. Lots of different approaches to this, loads of ideas that have come out in those opening presentations. How do we standardize all this around the world, Martin, then? Or do we even need to? Should we maybe retreat a bit from trying to standardize everything because, different cases will apply to different cultures, different countries, different markets, different people?
I don't think we need to standardize everything. And I think that's part of our problem in the past that we think one standard for food safety should be implemented everywhere in the world for every food. With regard to these approaches to risk assessment, trade-off risk assessment, I think we need to develop best practices, but we do need to recognize that it will be different in different locations with different levels of expertise, but also as technology changes. AI is going to move so fast that what we think is best practice today is not going to be best practice into 5 years. But yeah,
Yeah.
standardized models, more guidance is important in this space. And again, Codex, International Committee for Microbiological Specification of Foods, we have those groups that can and should take the lead on that.
Yeah. And then, of course, like a big, massive discussion at international and indeed United Nations level just to come up with that right term. You don't seem to like sufficiently safe very much. So if we could achieve anything today, just coming up with a better term, you think? All right. Well, I won't get too hung up on that, but that's been absolutely fascinating. So, a huge thanks to all of you, and for being so brief there at the end with those final thoughts as well. You've given us plenty to go away with and consider. So there we are, folks. I'm afraid that is it. We don't have time for any more. I'm really sorry if we didn't get around to your question, but we got through quite a few, and I really appreciate all of you around the world from all the different countries that I mentioned and some that I didn't, who have contributed so brilliantly to this discussion. And certainly my takeaway is one of real kind of optimism, I have to say. And I don't mean that in a naive way. I really do feel as if the right people seem to be in the room talking about this, and just kind of moving from hazard to risk. That to me seems doable. As a journalist, I was hoping maybe I could come up with something that would really provoke and catch people out, but it kind of makes sense to me. I'd love to know what you think, so let's keep the conversation going. But as I say, that's it for this session. But we will actually then keep the conversation going, as I say, on social media. And I do want to just remind you that we've had some great panelists today: Professor Martin Wiedmann, Shreya Sunil, Professor Sophia Jola, Steve Wern, and Frank Yanis. And do visit the Frontiers in Science website to read the article that's been food for thought for today. Now, remember all that related content too. There's lots there. There's something for everyone, whatever your expertise or background. So do keep the conversation going. As I say, on social media, the hashtag is FrontiersIn. That's hashtag FrontiersIn. That's it. Thanks to the brilliant team at Frontiers for making this event happen. They're absolute geniuses. Thanks to the panel. Thanks to you for watching. Bye-bye.